Hello, I'm Dr. Deepthi and we are looking at different concepts from maths under the heading Decreations Mathematics. For the past few episodes, we have been talking about the broad topic of linear algebra, and in that, our focus has been on matrices. We have done several episodes on matrices. Those of you who need to revise the basic concepts, you can see the previous episodes. We have seen what exactly is a matrix, then seen its real life application, also looked at its algebraic operations such as addition, subtraction, scalar multiplication. Then we have learnt about the important concept of matrix multiplication, seen that it is non-commutative. Also seen some types such as an identity matrix where all the diagonal elements have 1 and all the non-diagonal elements are 0. Then we looked at the concept of determinant. And in determinant, if you ask what is the application of determinant, then one prime application is finding out the inverse. So let us see how. So let us focus on the concept of inverse of a matrix. For that purpose, consider a square matrix A. Then take its determinant. If its determinant comes out to be 0, it will be called a singular matrix, and in that case, there is no inverse for that particular matrix, or it is non-invertible matrix. But if the determinant of the square matrix A is non-zero, then it will be called a non-singular matrix, and it is also an invertible matrix. That means for this matrix A, there exists matrix A inverse such that the product of A and A inverse is equal to product of A inverse and A, which is the identity matrix, which I just spoke about, that all the diagonal elements will be 1 and all the non-diagonal elements will be 0. So then this particular matrix A inverse is called inverse matrix of A. Now you must be wondering how to calculate an inverse. So let us try to find out how to evaluate inverse of a 2 by 2 matrix. For that purpose, we will consider A, which is a non-singular square matrix. Elements have being A, B, C, D. Then its inverse is given as 1 upon determinant of A into the matrix where the places of the diagonal elements get switched and the non-diagonal elements have to switch their sign. So A and D switch their places while B becomes minus B, C becomes minus C. And just for your recollection of facts, determinant of A is given as AD minus BC for this particular matrix, ABCD. So you multiply these elements and then subtract from them the product of these two elements. Right? So not very difficult. Let us see it through an example so that you will understand it better. So I am taking example of a matrix A here where the elements are 8, 5, minus 1, 3. It's a 2 by 2 matrix. So first task that I need to do is to find the determinant, because we know that if the determinant comes out to be 0, the question ends there because it cannot have an inverse. So let us find out the determinant of A. So 8 into 3 is 24 minus of minus 5. That means 24. So this is minus of minus, that becomes plus 24 plus 5, which is 29. So we have found out this determinant. So when we want to write the inverse, let us first write down the determinant. So this term is 1 upon 29, 1 upon the determinant basically. Now what happens to this matrix? Let us switch the diagonal elements. So 3 comes here, 8 goes there. And let us switch the signs for the non-diagonal element. So this becomes -5, this becomes +1. So A inverse will be given as 1 upon 29 into 3 minus 5, 1, 8. Now, the interesting aspect here is you can immediately verify whether whatever inverse you've got, is it correct or not. And how will you verify it? Obviously, you will use this condition which we talked about earlier, that the product of the matrix and its inverse has to be the identity matrix. So let's take the product of the matrix with its inverse. Now when you take that product, now it's straightforward. So this is 3 in minus 5. Please recollect the concept we have learned about matrix multiplication. If you are still confused, go visit the episode we have done about it. So 3 into minus 5. So 3 into 8 is 24 plus 5, which is 29, divided by 29. So it should give you 1. Then we consider first row and second column here. So 3 into 5 is 15, minus 15 is 0. So this term is straightforward, 0. Then we consider this term. 8 into 1 is 8, minus 8 is again 0. And now the last term, this row and this particular column. So 5 into 25 plus 24, which is 29, divided by 29, which is 1. So it gives you identity matrix of order 2. So we have verified that whatever we assume to be the inverse is definitely the inverse, because if you take the product of A with its inverse or vice versa, product of A inverse with A, it is giving you the identity matrix back. So this is the concept of inverse. It's not very difficult, isn't it? I hope you've understood it, and for anything, whether you have understood it or not, will be checked by giving you an example or giving you an exercise which you need to solve. So let me give you an exercise. Let there be two matrices. This is first matrix which has the elements 1, 3, 2, 6, and this is second matrix which has the elements 2, 3, 4, 5. Now you need to check, first you need to check whether they will have an inverse. Are they invertible matrices? And then if it does have an inverse, you need to evaluate it. So now I'm sure you are very well versed with how to take determinant. So simply multiply this 6 minus 6, that will give you 0. And m has to be non-invertible. Now I would suggest that when you read the exercise, pause the video, solve it for yourself, and then cross-check your answer. Right? So I presume that now you have solved it on your own and now you are cross-checking your answer. So determinant of m is 0. What about determinant of n? 2 into 5 is 10, minus 12 is minus 2. It is not equal to 0, so it is an invertible matrix. If it is an invertible matrix, you have to find out the answer. That means use this particular formula. So we have already found out the determinant to be minus 2. So 1 upon minus 2. And in the matrix, we know we have to switch the diagonal places. 5 comes here, 2 goes there. And reverse the signs of non-diagonal elements. That means this becomes minus 3, this becomes minus 4. So inverse is 1 upon minus 2 into the matrix 5 minus 3 minus 4, 2. And you can just multiply this particular matrix 2, 3, 4, 5 with this matrix n inverse and cross check. If you are getting the identity matrix, that means your answer is correct. So here you yourself are able to verify whether you have got a correct answer or not. That is the beauty here. Okay, so we will stop here for this episode and keep meeting again and again for many interesting concepts in maths. Thank you.